Hi, I will be talking about vertical federated learning on Scattered Directive and how we enforce policies on VFL workflows running distributed across the world. We researched the feasibility of a VFL workflow integration into a distributed policy-driven digital data marketplace platform. To that extent, we researched the benefits that policies bring to VFL workflows, how VFL can be expressed in data exchange archetypes, and to what extent DDM platforms can be deployed in a distributed fashion. Our research aims to solve the issue that agreements are never perpetual. Legislation, court orders, company policies. Many things can change what is and is not allowed. Current systems require a manual labor to adapt or stop VFL workflows, and current research focuses on the algorithms of VFL, not on policies in combination with distributed infrastructure. In a general VFL workflow, there are several organizations that have private data, and they jointly trust a server to perform aggregation on a global model. With a three-step training round of local training, global aggregation, and local gradient descent, a model built on private data can be jointly created. As mentioned, we will be using Scattered Directive. It is a distributed and reproducible DDM that runs on the Fabric testbed, allowing for cross-continental deployments of clusters. Under the hood, it utilizes request overlays to enforce data exchange policies, which are set by the different collaborating organizations. Any violations of these policies are barred from running by Scattered Directive, but these request overlays increase memory usage and startup times. Scattered Directive utilizes policies. These policies consist of organizations, resource constellations, and the policies and agreements that are made within this context. A data exchange archetype defines where certain data lives and where it is allowed to go. This concerns data, software, and output. Previous research defines two classes of archetypes, namely Class A and B. Class A archetypes consider a constellation of two organizations working together, while Class B archetypes consider three organizations. Resources are spread across the organizations in various manners. This is the resource constellation. Each unique resource constellation is considered a data exchange archetype. Our related work considers policies and vertical federated learning. Research by Kassam et al. Considers a privacy by design framework. This framework requires explicit permission requirements, such as which are necessary in healthcare, and utilizes a formal normative language, such as EFLINT, for policy definitions and the reasoning on policies. Their work considers how to reason about these formal policies and how that can be utilized in these data-sensitive contexts. VFL research covers a wide area. The research by Corinne considers cerebrovascular accident outcome prediction, utilizing various sources of healthcare data to create more accurate models than is otherwise possible with a single source. Various studies consider privacy-preserving techniques for VFL workflows, such as ADMM, which allows for more than one local training round per aggregation, XGBoost for distributed label data, and VFL unlearning. Finally, Flower is an FL framework that abstracts the lower level implementation to allow researchers to focus on FL workflows. Our first research question asks of the benefits of policies concerning vertical federated learning. We highlight three areas in which we believe policies are beneficial. The first is privacy-preserving algorithm requirements. Policies, either defined by organizations or legislation, can define which privacy-preserving algorithm should be utilized. One low-level policy that could be considered is execution cycles. certain privacy-preserving algorithms specify the maximum number of iterations a vertical federated learning workflow is allowed to have. Moreover, the amount of data that organizations have could influence this as well. Policies automate the handling of this. Next up, conflict resolution strategies can be defined using policies. Dan Roosendaal from the University of Amsterdam is presenting his paper on conflict resolution strategies in vertical federated learning at this conference too. Policies can automatically define how the VFL workflow ought be executed in the face of conflicts. Finally, automatic verification can guide the policy-making efforts, as it can check whether sets of policies can work in tandem. This could be achieved with a formal normative language such as EFLINT. When we consider current data exchange archetypes defined in previous research, we notice the lack of an integral archetype class. When we try to model VFL workflows, the current classes offer no support for arbitrary number of data providing and output receiving organizations. This is why we have expanded policy theory with a third class, Class C. In this class, we broaden the scopes and define that data and output can come and go from any number of organizations. We redefine software to accept multiple sources of data and provide multiple sources of output. And we define that policies in Class C have to concern agreements between all parties. This must be the case. When you consider n separate organizations communicating with Organization O, Organization O should only be allowed to combine all the data if every organization allows this through policy. Within this archetype class, we defined shared execution via a trusted third party. This archetype specifies that every organization provides data to a trusted third party and receives a corresponding output from the trusted third party. The underlying requirement for shared execution via a trusted third party is that every party has an agreement with each other. What is visible is the relation with vertical federated learning. Private operations are utilized to turn private data into embeddings through local training. The embeddings are sent to the trusted server, and software considers all of the gradients at once to do global aggregation. Then, gradients are sent to the respective organizations, which are then used in another private operation to apply gradient descent. For the implementation of a VFL workflow on Scattered Directive, 3 elements were required. First of, the shared execution via a trusted third-party archetype. Implementing this archetype required adapting Scattered Directive to allow for a number of organizations to provide data, and to provide output to that same number of organizations. We also needed to make it possible for the trusted third party to receive every single data input. Secondly, we implement multi-cycle execution. This allows us to run an arbitrary number of rounds for a given request. This relates to how VFL utilizes many training rounds to reach a high accuracy. Every single cycle requires the policies to be re-verified. This must be done because policies can change at any moment in time. Finally, the VFL workflow is implemented with a linear regression model utilizing the Titanic dataset, where the data is split into 3 clients. The simplicity allows us to focus on the overarching implementation of VFL on Scattered Directive, and the Titanic dataset offers heterogeneous data for more realistic VFL scenario. When we look at the results, we are able to see converging accuracies for every single round of training that we have executed. The first thing that this tells us is that our implementation is correct. Secondly, we see that the accuracy of our models increase past the accuracy of other research utilizing the Titanic dataset. These researches, however, do not utilize VFL. This means that we are seeing no hinder from our data being separated. When we look at longer VFL workloads, we see a comfortable accuracy increase over one of the other researches, and we are nearing other research accuracy numbers. Finally, when we have a look at the policy changing implementation, we are able to see that Scattered Directive properly stops VFL workloads from executing whenever a policy change is introduced into the system. This policy change has the immediate effect of a third client exiting the agreement, meaning the agreement is not allowed to continue. Scattered Directive properly handles this case. Further research on this topic can consider integrating a VFL framework such as Flower into Scattered Directive. Another venue could be hardening the security of Scattered Directive by introducing ephemeral services in combination with data persistence. Finally, there is a lot to explore surrounding the newly proposed archetype class C. Other data exchange archetypes within this class can be defined and utilized in further research. To conclude, VFL workflows are possible within a policy-aware DDM. A new archetype class C was defined to facilitate this functionality, and within that class, the shared execution via trusted third-party archetype. With our results, we demonstrate the automatic adjustment of the VFL workflow based on policy changes that have been dynamically introduced into the system. This reflects how organizations or legislation can affect what is and is not allowed at any moment in time. Overall, the proposed archetype implementation in Scattered Directive was shown to provide a strong foundation for collaborative VFL use cases in DDMs. Thank you.